In this video, we will learn about the most important data structure, tree. A tree is a collection of nodes and their vertices, their edges. That is called tree. And we will learn about the terminology of tree. And here, first we have to learn root of this tree. The root of this tree is A because there is no coming edges to A. This is the root, and for B, I and H is the children of B. That is, B is the parent of I and H. So, this is parent, this is root, and all these are edges. Edge, this one of edge, this is another edge, this is another edge. So, root we have learned, parent we learned, child we learned. So, what about the siblings? The siblings is a collection of childs from the same parent. See, for D, there is 3 children, that is G, F and E. So, G, F and E together, they are the siblings of D. This is the parent and G, F, E together is their siblings. And what about the descendants? The descendants is for B, I, H and J, they are all the descendants of B. They are all descendants of B. So, what about the ancestors? From ancestor from J, node J, we can go back to the root node. If you go back to root node for J, its ancestor, very immediate ancestor is H, and H, for H, its very immediate ancestor is B, and for B, its very next ancestor is A, which is root node. So what about the degree of node? The degree of node for B node, there is 2 child, I and H. That is, B is a degree of 2, and here for J there is no other child. Left side and right side is 0. That means it has only 0 degree. It is 0 degree. And here for D, D is a degree of 3 because there are 3 children, that is G, F and E. And K, for K is degree 2, that is L and M. So now come to the next point, that is internal and external nodes. So what are the internal nodes? The node which has at least one child, that is called internal node. That is, for B is an internal node because it has 2 children and it is degree of 2. That is why it is internal nodes. For C node, there is no child. So this is external node. And here for J, there is no node. That is external node also. And if there is no node, if there is no child from that very particular node, then we are called this type of node leaf node. We call this as leaf node. Suppose from here also J has no children from on left side, either on right side. We can see it is 0. That means it is 0 degree only. So it is also external node or leaf node. M is also leaf node. E also leaf node, G also leaf node. but F, K, B, H, they are not leaf node or external node. We call them as internal nodes. Now what about the levels? The levels of a tree we define as from root 1 we count as 1, this level we count as 2, this level we count as 3, this level we count as 4, this level we count as 5. So level of this particular tree we can see that it's 5. And now it is height. What about the height? Height is counted depending on their edges, so here we can see that height is count from 0 only, because from root node there is no edge, that's why we are defining it, we are declaring it from 0. And after that, from A to B, that is one edge, this is one edge. So this is 1, 0, 1, that is 1 and 2, that means from A to I, if you want to come here to till I, then we have to cross about 2 edges, that is A to B and B to I. So this is the height, 0, 1, 2, and what about this? 1, 2, and 3. So the height of this tree is 3. And what about the forest? A forest is a collection of tree. Suppose if you disconnect this edge, if you consider this only B, I, H and J, this is a tree. Even only one node C is a tree, even only one node A is a tree, and this one, the right side, this is a tree. If you combine this together by joining them by H, then we are going to call this forest. We are going to call this as forest. Now we are going to learn about the binary tree. We have already learned about the degree of node. A tree is defined as binary tree which has degree of 2, that is, this is a node B left side and C. This is a binary tree. So for binary tree, for at most the degree of the tree will be 2, less than 1, less than 2, but not more than 2. Suppose this is also binary tree. This is also a binary tree, only one node. This is also binary tree. Now if you consider this tree, this is not a binary tree, because why? It has 3 children, and as per the definition we know that a binary tree, it should have at most 2 children and minimum 1 or 0 children it can have, but not more than 3. So this is not a binary tree. So in the coming videos, we will directly jump to the important topics, important problems that is related to binary tree, and we are going to discuss them, we are going to analyze them about their time complexity, about their space complexity. Step by step we will learn by coding using in Python. we are going to code them, we are going to solve them in Python. So in this video, that's all. In next video, we'll learn different topics.